This is the Illinois Nutrient Loss Reduction Podcast, Episode 5, Fall Tillage and Fertilization Do's and Don'ts. I'm Extension's Todd Gleason. We're now joined by Doug Gooker and Jennifer Woodyard, both from University of Illinois Extension, to talk about water quality and nutrient loss. Doug, let's start with you. What impact does fall tillage have on water quality?
Well, fall tillage, anytime we do tillage, it disrupts soil structure. And when we disrupt soil structure, then it's much easier for rainfall, freeze-thaw cycle to make that soil able to move, and whether it's moved by the wind or by the rain. And so even out where I live on the flat prairies, we have water movement even out on the flat prairies, and we see erosion, not near like you do on sloping fields. Sloping fields, we see lots of erosion. And if farmers are doing tillage in the fall and they're doing it up and down slopes with no regard, and they're using disc rippers that are leaving less than 10% residue cover, there's very little difference between that and the moldboard plow. The term conservation tillage with a disc ripper is awfully hard for soil people to come to grips with, because we have less than 30% residue cover, and that is a minimum we need if we're going to have any type of tillage and not have significant soil movement. We'll still have soil movement with 30% residue cover, and the best would be not to do any tillage in the fall, or if you do tillage, use cover crops immediately thereafter.
Jennifer, you have some more information, kind of data about this. What do you know?
So when we think about tillage and soil erosion, there is a value used called T, which is considered the maximum rate of erosion that does not damage the productive potential of the soil. So depending on your soil's characteristics, T can be anywhere from 1 to 5 tons per acre per year. So in the nutrient loss reduction strategy, one scenario shows that if 1.8 million acres of conventional tilled ground that is eroding at a rate greater than that T value were to be converted to reduced mulch or no-till, we would see the amount of total phosphorus loss on those acres reduced by 50%. So, and then another scenario in the nutrient loss reduction strategy shows that if cover crops were put on 1.6 million acres that are currently using reduced or no-till, but they're still eroding at a rate greater than T, we would see total phosphorus loss from those acres also reduced by 50%. Some of these practices that are listed in the nutrient loss reduction strategy are really going to help us reach those goals. We have an interim goal by 2025 to reduce phosphorus loss by 25%. And we want to reduce nitrogen loss by 15%. So I encourage all the producers out there, if they haven't had a chance to take a look at this nutrient loss reduction strategy, to really look at it and consider how some of these practices might fit in on their operation.
The university's done a lot of work, different subject area, same problem, relatively speaking. Instead of soil movement, we're talking about nutrient movement this time. The university's done a lot of work looking at nitrogen applications. What do we know about splitting, for instance, nitrogen application in the spring and the fall, and how well that works?
Well, we know for a fact that if we put nitrogen on the fall, with there being no growing crop on fallow ground, which is very typical, that we run and usually do have a risk of loss. Even with a nitrification inhibitor, we will still have some loss. We won't have near the loss as if we don't use a nitrification inhibitor, but we still have a loss. And so we understand with farming that getting all the nitrogen on in the spring or during side dress may not just be physically possible for farmers. I mean, just physically possible. But the idea of only putting on 50%, it greatly reduces the amount of nitrogen that is susceptible to being lost through leaching.
Are there potential issues that farmers might face if they decide to do a split application or to do side dress?
Timing. Having side dressed in the past, it never rains until it's time to side dress. And so you have to have a plan B. And so if it's too wet to side dress, how are you going to do it? The other thing is that are there ways that you can side dress that are quicker than maybe pulling an anhydrous tank down through the field? Can you use 28 and use rolling Coulter applicator where you can roll at 8 or 9 miles an hour and cover, and you have a 24-row applicator so you're covering. If you're going to side dress, you're going to have to be geared up and equipped to do it, or have a plan B, such as a custom applicator that can come in with high clearance equipment to get that N on.
Finally, do you have really any advice for producers who are looking to switch either to no-till or spring applied in?
Okay, for no-till, having been a no-tiller and starting over 30 years ago, back in the dark ages, the biggest thing is that no-till actually works extremely well with cover crops, because when we go to no-till, our soils are used to this constant turning in conventional agriculture. So we have a very high bacteria count, but we have very few of the fungi and other organisms that really break down residue well. And so if in the first few years of no-till, we can end up with a residue mat, a heavy residue mat, where if we use cover crops, this rapidly brings in these organisms that help decompose, and we don't have those traditional issues in no-till. The other thing is that no-till now, we consider strip-till to be no-till. And quite honestly, if you're going to do no-till, do strip-till, because you're still tilling 1/3 of the ground when you put that strip in. You're just not tilling the other 2/3, and you don't really need to till that anyway. So you can till that 1/3 where you're going to plant the seed. You're going to make a nice raised bed to plant it in. So next spring, the row middles may be wet, but that nice raised bed you created last fall is going to be nice and warm and ready for you to plant in. And besides, you can then put your phosphorus down deep in the fall, which is even better way to keep it from moving.
Jennifer, Doug talked about several things as it relates to nutrient loss, using a nitrogen inhibitor in the fall, maybe split application, or even side dressing. What do the statistics and science tell us about these?
Yeah, so I talked a little bit about the phosphorus practices, and then there's also the nitrogen side, of course. So as you're going into harvest and thinking about what you're going to do after harvest, if you're going to apply nitrogen in the fall, you should really consider putting on a nitrification inhibitor. So in the nutrient loss reduction strategy, they talk about if we were to use nitrification inhibitors on all tile drained corn acres, we could see a 10% reduction in nitrate N loss per acre. And then thinking about doing a split application, so if you did 40% in the fall, 10% pre-plant, and 50% side dress, we could see a 15 to 20% reduction in nitrate N loss per acre. And on a similar note, if we switch to only spring applications of N on tile drained corn acres, we could still see that 15 to 20% loss reduction in nitrate N per acre.
One final note, anything a producer just should not do this fall?
Yeah, so if you're going to till this fall, you really don't need to till soybean stubble. There's not a lot of residue there, so when you go in and till it, you're just really removing that and kind of exposing the soil to erosion this winter. And then it's really important to at least keep residue cover on sloping soils, especially because we can see a lot of water erosion and wind erosion occur there during the winter as well. And then if you want to apply anhydrous in the fall, really you need to wait until soil temperature is at 50 degrees, which is normally about November 1st. And then consider applying a nitrification inhibitor with that so that we can slow that conversion of ammonium to nitrate.
Thank you, Jennifer. Jennifer Woodyard and Doug Gooker are both with the University of Illinois Extension. They join us on this 5th episode of the Nutrient Loss Reduction Podcast. I'm Todd Gleason.